Hello everyone. As said, I am Nico, and I come from the land of game dev. I'm also currently on the R&D team here at BBD, and I'm a cultivator of the beard. I'm also a connoisseur of good coffee and a companion to all puppies. And you can't see it really there, but you should take everything I say with a grain of salt. Today I'm going to talk to you about entity component systems. Henceforth I will call it ECS. I'll tell you what ECS is, why it's awesome, why it sucks, and how you can get started with it in your own projects. But first we must identify the problem that ECS is trying to solve. Game dev is dominated by OO, which is not a problem in itself, but it does lead to the rise of two other problems, namely random memory access patterns and cache misses. In my opinion, it also causes you to write some inflexible code via inheritance hierarchies. ECS is one of the options you have to solve those problems. It is worth noting, however, that ECS is not a library, it's an architectural pattern. It's also a way to organize and process data. There's three main parts to ECS, as the name suggests: entities, components, and systems. ECS is very common in games and simulations, especially now since big engines such as Unity has made a pivot to implement more pure versions of ECS to benefit from the performance benefits. It's also been claimed to be the future of MMO games, or multiplayer online, for Jerry's benefit. However, ECS is not a silver bullet, and we'll get into it later. One of the core concepts of ECS is data-oriented design. And this is the dictionary definition, sort of data-oriented design. Data-oriented design is an approach intended to maximize the locality of reference by organizing data according to how it's traversed in various stages of a program. ECS focuses heavily on data, and the aim is to write sequential, homogeneous chunks of data that can be sequentially, as much as possible, be read and minimize cache misses that way. So the benefits of ECS is code decoupling through the way that its systems are structured. Obviously the blocks of homogeneous data. ECS is also scalable. You can easily extend, refactor, and debug your code. There's clear context within your systems, as you know what data to expect and what entities you'll be working or processing with that system. Serialization is made easy with ECS because entities are just collections of data. Parallelization is also made easy because you can just take a system and put it into a separate thread and it works. ECS is as generic as you can make it. It's just data and it's just generic. Some of the drawbacks of ECS. The workflow can be slower at first because it's unfamiliar and you often need a paradigm shift. Unfamiliar. ECS can also be challenging to interface with existing code bases. There are some limited use cases for ECS. You're mostly going to use it in games and simulations, especially big ones that have lots of things in it. ECS doesn't really have data hiding unless you specifically go and work to do that. Yeah. So the entities of ECS, they're just containers of components, and they're usually just a unique ID. The aim of entities are to have no dangling references when you destroy them. Here's an example of entity. So it's just a thing with some components. Components of ECS They have no logic, they're just data. An example of it is if we add a health component to this entity, we're making it mortal because our health system will pick it up and immediately start processing on it. Systems, they're the logic of our program, and they contain no state, or ideally they shouldn't. They're self-contained and decoupled from other systems as much as possible, and they know what data to expect through either queries or filters they use. And they follow the separation of concerns pattern. Systems don't care what the entirety of an entity looks like. They only care about the relevant parts that they're querying for. So this system here, the render system, is querying for entities that have both a position and a mesh component to it. So there's this entity, but it doesn't care about the health at all. So now I'm going to show you a bit about ecsy. But first, ecsy is a new experimental ECS for the web from the Mozilla mixed reality team. Okay, so here I have a very simple HTML file. I've just set up a canvas and some styling in it, and a script module. So when working with ecsy, first thing is we import ecsy. I'm just using a link, but it's also available on npm, whatever package system you like. And then we need to just set up the canvas so that we can get screen sizes and the context to actually draw things. And now we start with a component. This one is just the position. And you'll notice that I am using this helper function called create component class, which does all the hard work for you and sets up the whole object. It sets up reset functions and stuff like that so that your component can actually benefit from object pooling. Oops.
It's going to break later.
It's going to break later, yeah. And then let's add a render system. Right, so render system is a little bit more. So let's break it down. The render system is just a class, and it has this query down here, which indicates that it's looking for all entities that have a position component on it. And it has this execute function which gets called to make the system execute. This system is just iterating through all the entities we found in our query and drawing a circle wherever our position is, like so. And then we just need to set up the world. So most ECS systems run off this world object, which is a container of your entities and your systems. You can have multiple of them if you like. You also register your systems like this onto your world. However, we don't need that one now, so we're just going to render. And we also don't need this component here. I'm just creating 100 entities with position components, random positioned. And I'm using a set interval for simplicity's sake, just to make the world execute. You can use things like request animation frame to make things a bit better. And you can actually use delta time and stuff like that. So yeah, let's get this just running. There we go. So we have a bunch of dots being drawn. It's not all that exciting. So let's add some movement to it. First thing first, we need a velocity. So let's go add another component. There we go. Which is pretty much the same as the position. It's just a vector. And then we need to add the movement system. This one's a little bit more complex. it queries for entities that have both a velocity and a position. And I'm using this get mutable component function here, which indicates to ecsy that I'm actually going to change data within these components. And I'm just making them move based on the velocity and bouncing them when they exit the canvas. And then we need to register that system on here. Right. It's worth noting also that systems execute in the order that you register them onto this world. And then we need to add back this velocity component over here, just giving it a random velocity. And now we should have some moving dots. Yay! So in conclusion, the takeaways are that ECS is great at high volume processing of data when you have games and simulations such as strategy games, bullet hell games, crowd simulations, anything that has a lot of entities and things moving around and doing stuff. Consider ECS if performance is key within your game or your project. If performance isn't really that much of an issue for you, maybe ECS isn't really the solution you should be looking for, as ECS may get in the way of anything that has more complex or unique behaviors. Dirk over there will tell me about character controllers and things like that. So yeah, does anyone have questions?